for a while, but I just didn't want people to forget about that kind of thing. So topic 5.3, day 1. We are on to proofs, guys. I know this is a perfect timing for going fully virtual, but that's okay. Hopefully these proofs should be a little bit better. Something to think about. Do you guys remember back when I gave you those vocab sheets? Maybe? Okay. I would try your best to dig those out. I will link a new vocab sheet into this class or next class's directions, not a new one, but I'll go back and link the old one in. It's very helpful because we're going to be dealing with a lot of old vocab like vertical angles, angle bisectors, midpoints, things like that. So you need to be aware of what those definitions are, what those things do, or you at least need to be able to go and like look it up. Okay, so I would try to dig that out, and just in case someone can't find it, I will send that out and link it into today and next class's directions as well, just in case you need a new one. So what we're going to be doing today is proving that triangles are congruent. Now, if two shapes are congruent, can someone refresh my memory? What does it mean if two shapes are congruent? What does that tell you about them? Come on, guys, be brave on the Google Meet. Okay, yeah, the sides are going to be exactly the same. The angles are going to be exactly the same. The shapes are the same size and the same shape, right? The angles are the same. The sides are the same. Now, think about if we wanted to prove that two triangles are congruent. Potentially, wouldn't you have to go through and prove that all three sets of sides are congruent and that all three sets of angles are congruent? That would kind of be a pain in the butt, right? I don't want to have to do that. I don't want you to have to do that. That's a lot of stuff. So what we're going to be talking about today are shortcuts that we use to prove that triangles are congruent to each other. So that way you're not sitting there proving three sets of sides and three sets of angles each time. There's other things that you can show that will imply that everything else is still congruent. So these are our triangle congruence theorems. There are 5 of them. They each have a little abbreviation. So in this table, we're going to talk about what the theorem is, what it might look like in a picture, and then explain it. Okay. So we're going to be doing some like extra labeling and stuff here, just a heads up. So our first theorem is the side angle side theorem, abbreviated SAS. What this theorem means is that two sides, oh, sorry, hold on, my stylus turned off. So this means that two sides and what is called the included angle are congruent. So two sides, any two sides of your triangles are congruent. So if you look at this picture here, I can clearly see that side FE is congruent to BC, right? Those are marked. So that's one side. So what I'm going to actually do to kind of show you is actually write on this a bit. This is one set of congruent sides. I'm just going to label it on one of my pictures. Then we have another set of congruent sides. Down here, AC is congruent to DF. So there's another set of congruent sides. So that's the side part of this. Now we just need an angle. Now the trick with this is the angle can't just be any old angle. You'll notice here that it says the included angle. Does anyone think they might know what that means? And you can kind of look at your picture and see if you can tell. What do you think an included angle is, or where does it need to be in your picture? Okay, yeah, it actually needs to be on the inside of those two sides. So if you take a look, if I look at side FE, right, and side FD, don't they both connect at angle F? And then if I look at side AC and side BC, don't they connect at angle C? So it's where those two sides connect. They connect in the one picture at angle F, they connect in the one picture at angle C. So F and C here are my included angles. They're the ones that are formed where those two sides connect. So we have that angle C and F are congruent. So that is our set of congruent angles. So here is my set of sides, set of angles, set of sides. And if you kind of look at your picture, it almost like says it to you. It spells it SAS if you go around your picture, okay? Side, side, side is a pretty easy one to notice because you're only looking at sides. So we're only looking at our segments. This means that all three sides are congruent. All three sides are congruent. So here we have that side BA is congruent to DE. That's one set of sides. We have that EF is congruent to BC. That's another set of sides. And then we have DF is congruent to AC. So if you label this, we have a set of sides here with BA and ED. We have a set of sides here with BC and EF. And then we have a third set of sides with CA and FD. So all three sides are congruent here. All right. The next one we have is called hypotenuse leg. Key word with this is hypotenuse. Does anyone know what a hypotenuse is? Does it? Well, it might sound familiar at least, right? Anybody think they know? All right. Anybody? Nobody? Nobody knows? All right. A hypotenuse is a side that only happens in a right triangle. The hypotenuse is actually the side across from the right angle. So you have your right angle, it's the side across from it. Does that sound familiar, guys? Okay, good. So it's the side across from your right angle. So what that means, if this theorem is called hypotenuse leg or HL, then it only works for right triangles. And I would write that down. Since you have to have a hypotenuse, this only works for right triangles. If it's not a right triangle, then you cannot use this. Now, that doesn't necessarily mean that every time you have a right triangle, it's going to be hypotenuse leg, but many times it'll happen. Okay, so what happens here is that the hypotenuse, so that's the side across from the right angle, and one of the legs are just either of the other two sides are congruent. So hypotenuse leg. Number one, it's a right triangle, which here we can see it is a right triangle. We have our box in the corner. We have our congruent hypotenuse right here, ED and BL, that is our congruent hypotenuse. And then we also have a congruent leg with FD and AC. So a leg is just either of the other two sides of your shape. So we have our congruent hypotenuse and a congruent leg. Then we have angle side angle or ASA. That means we are going to have two angles and the included side being congruent. So two angles and the included side are congruent. So two angles, any two angles at all in your picture. So here we have that angle A is congruent to D. We have that angle F is congruent to C. So there are our two congruent angles. So here's an angle, set of angles, set of angles. But in order for this to be angle side angle, we also need a set of sides. Now, hopefully you noticed it says included again. When we dealt with our included angle, it was the angle where the two sides met, right? In this situation, it's kind of the opposite because it's the included side. The side has to be the segment that connects both angles. So if you look at your picture here, it has to be the segment that connects from C to A, and then the segment that connects from F to D. So this has to be your set of congruent sides. And if you label this, do you guys see the ASA? And isn't that your abbreviation? So I would recommend labeling here, and that really helps you decide which theorem it is. So you got a set of angles with C and F, another set of angles with A and D, and then your included side is the side that connects from C to A and from F to D, and we can see that those were congruent as well. And then the last one is angle, angle, side. Now I'm just going to warn you, these two are mixed up a lot. Angle, side, angle, and angle, angle, side. Can anyone maybe see why they're mixed up a lot? Any ideas why these are often confused? They look really similar. Don't they both have two angles and a side? Right? They have a lot of the same stuff going on. The key thing though, in the difference, this first one was angle, side, angle. The side had to be the one that connects the angles, hence why it's in the middle, right? This one though, the side's not between the angles. That means this side does not connect the angles. It's some other side in your picture. So what our theorem is here is that two angles and a non-included side are congruent. So you're still going to have your two angles, any two angles at all. Here we got A with D, and we got F with C. So there are our two angles. Set of angles, set of angles. But which set of sides is congruent here? Do you guys see it? Which set of sides is marked as congruent? Yeah, BC and EF. That does not connect our angles, right? AC connects our angles. DF connects our angles. This is just some other side. So it's the one that does not connect the angles. And then again, if you label it, you can see you have an angle, angle, and then a side. I've been asked before, why isn't it side, angle, angle? That's just not what it's called. It's not its name, right? Technically, I guess it'd be the same thing. It's just not the labeling that's used. Oh, that's okay, Al. Yeah, I don't know. You have like some weird feedback on your mic. I'm not sure why though. Do you have the Google Meet open on two devices maybe? That's probably why. So what you need to do then is mute one of them. Whichever one you're not talking into, mute yourself on it. And then that should fix it. So like I have two computers up right now and I have to mute myself on one or else it does weird feedback. So it's muted, is your volume turned all the way down? I would turn your volume all the way down too. I have to do both on mine, on my MacBook. That's perfect. Yeah, I've had the same issue, so I figured that out too. I have to both mute it and turn my volume all the way down. All right. So what we're going to do here is decide whether enough information is given to prove the triangles are congruent. If so, state the theorem you would use. So again, our options are side, angle, side. Side, 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 hypotenuse, leg, angle, and angle, angle, side. Now, there are a few key things that you want to look for in pictures, and they're going to occur again and again and again. Before we even start, take a look at this first shape. I'm confused. This looks like one giant shape. How is this two triangles? I don't get it. Anyone see the two triangles? Yeah, aren't they just like kind of connected with one of their sides? Yeah, so you actually, in a picture like this, in a picture like this is two triangles that are connected to each other. You got a triangle here, and we have a triangle here. These are two triangles connected. This happens a lot. Okay, this happens an awful lot. Then, I'm switching between my colors too quickly and it's messing up. There we go. Then, in this picture, you guys remember your bow tie shape? Anyone remember what special kind of angle always happens in your bow tie shape? Yeah, vertical. So these are two big things to look for. Bow tie shapes, you're going to have vertical angles, and shapes that are connected, they're going to be connected along a side. So if we look at one here, we got to decide, is there anything else that we know is congruent? If so, what? And we got to decide which theorem works. Now, I really like to label these. I would pick one triangle to label though, or else there ends up being too many letters written down and you get confused. So in this one, I have a set of congruent sides here on the right. So that is one set of sides because they had the little dashes. Then here on the left, I have another set of congruent sides. So far, I have a side and a side. Something that I would kind of do while I'm deciding this is use a little bit of process of elimination. Side, angle, side. Currently, I have two sides, right? So is side, angle, side maybe still a possibility? I would just need to find that congruent angle. That's still maybe an option. Side, side, side. Well, I have two sides congruent. Maybe I can find a third side. Hypotenuse, leg. What kind of triangle does hypotenuse, leg work for? Only works for right triangles. Is there anything here that'll tell me this is a right triangle? No, so hypotenuse, leg is not an option. Angle, side, angle. Well, don't we have two congruent sides? Doesn't angle, side, angle only have one congruent side? So that's not an option, which also means angle, angle, side is not an option. Those both have two angles. This one has two sides. So that means it either has to be side, angle, side, or side, side, side. We got to figure out what else we know because only two sets of sides were labeled. If you take a look, your shapes are connected along this side, aren't they? Think about if you took these two triangles and you separated them, you popped them apart. They would still both have that side, right? And if they're connected perfectly like that, that side is on one shape and on the other shape. That means it's congruent. They share a side. Anytime you have a shared side here, we can say our shared side is congruent to itself. So I would make a note of this here. Shared side is always congruent. So anytime you have a shared side like that, it is always congruent. So what do we think? Is this going to be side, angle, side, or side, side, side? Yeah, because here was our third side here. And again, if you label it, can we clearly see SSS? That's why I really encourage you guys to label it like this. So this has to be yes, by side, side, side. Let's look at number 2. Number 2, we have a set of congruent sides here. So there's one set of sides. We have another set of congruent sides here. What else do we know? When we have our bow tie shape, what else do we have that has to be congruent? Vertical angles. So we're going to mark those. These are our vertical angles. So we have, sorry, I cannot draw a neat S on this to save my life. Still, pretend that looks like an S. So here we had our 2 set of sides that was given, and then our set of vertical angles. Now, take a look. Does this look quite like SAS? Same letters, right? But are they in the right order? Can anyone tell, is that angle in the correct place? No, this angle is not in the correct place. In order for something to be side, angle, side, the angle needs to be where those 2 sides meet. It would have had to be these angles, right? Think about if I put a little A there, then wouldn't you see side, angle, side? But that's not what I was given. I was given a vertical angle here. So take a look. If I look at how this is read, isn't this either SSA or, read it backwards, ASS? Do you think there's going to be an ASS theorem? Probably not. Thank you, Gannon. I agree. I would say no. This does not work. So this is just a no. There is no angle side side theorem. It's not a thing. That angle is not in the correct spot. So we are going to say not, we're going to say no, not congruent. That angle was not in the right spot for it to be side angle side. All right. Let's take a look at number 3. In number 3, we have a set of congruent sides here with AB and CB. So there's a side. And we have a set of right angles. Now, if you have right angles, is hypotenuse like a possibility? Yes. We don't necessarily know for sure if it is, but it's on the table, okay? But regardless, also, if they're both right angles, all right angles are congruent. So we also at the same time have a set of congruent angles. So we'll see which one it ends up being. So since I scrolled over, remember our options are side angle side, side side side, hypotenuse leg, angle side angle, and angle angle side. On this list, if I have, we want to kind of use a little bit of process of elimination here. I don't know why it's glitching right there for some reason. But let's use a little bit of process of elimination. Does anyone see something on this list that is just not going to be an option? If I have one side and one angle so far, I see something on here that's not going to be a possibility. Yeah, side, side, side's not a possibility. We would have at least needed 2 sides to start with, right? Not an option. Side angle sides on the table, hypotenuse legs on the table, and I guess the other ones kind of are too. So we got to look at our picture. Does anyone notice something about our picture? We talked about it with number 1. Which one? Yeah, we have a shared side here. These two triangles are connected on line BD. That is our shared side, and our shared side is always congruent. So there is our other set of sides. Now, if you take a look, which theorem do you guys think this is? Yeah, SAS. Look at how it's written. We have a side, we got the angle that connects them, and then another side. So it has to be side, angle, side. Now, if you're looking at this and going, why not hypotenuse, leg? Can someone tell me where the hypotenuse is in one of these triangles? Someone I haven't heard from yet. Where's the hypotenuse in one of these triangles? Let me know that we are awake and that I'm not only talking to like 4 people. Yep, absolutely. AD is definitely one of the hypotenuses. And do I know that that's congruent to the other one? Is there any, are they marked as congruent? No, we just don't know enough information, right? They'd have to be connected there, or it would have to be marked for us. I just don't know. They're not marked as congruent, so I can't say for sure because they're not a shared side. So that's what you would have to use hypotenuse leg here. You don't have that the hypotenuse is congruent. So since we don't know that the hypotenuse is congruent, we know that's not an option. Angle side angle is not an option because we don't have 2 sets of congruent angles. And then same thing for angle, angle, side. That's not an option because again, we don't have 2 sets of congruent angles. So this has to be yes, by, side, angle, side. Okay. All right. How are we doing so far? L is good. Is anyone else okay, or is anyone confused? Do I need to re-explain anything? Okay. All right, number 4. Let's take a look. What do you guys see? Someone tell me one thing that you see in this picture. Anybody at all? Yes, I also see a congruent side. Right here, we got one of them, right? What else does somebody see? Yep, I see a set of congruent angles here, as well as here. So I got a set of angles and another set of angles. So let's go through. If I have 2 angles and a side, what are my only 2 options? If I have 2 angles and a side, what are my only 2 options? We can look at our list if we need to. 2 angles, 1 side. Yeah, good, Natalie. Those are my only options. Angle, side angle, or angle, angle, side. The question is, which one is it, right? So if you look at your picture, to decide which one it is, you got to look at where your side is. Does this side connect my 2 angles, or is it just kind of doing its own thing? Is it one of the other sides? So is it connecting the 2 angles, or is it not connecting the 2 angles? What do we think? Is it connecting or not connecting the 2 congruent angles? I agree, Gannon. It is not connecting. The side that connects them is this one. I don't know anything about that side. This side is not connecting them. So if it's not connecting them, do we think it's angle, side, angle, or angle, angle, side? Anybody? You got a 50-50 shot. Absolutely, it is angle, angle, side, Anna. Because that side, if in order for it to be angle, side, angle, that side has to be in the middle, and it is not. Angle, angle, side. Very good. So the other thing to kind of look at, guys, one of the reasons why I really want you guys to put the A's and S's on your picture is if you take a look at like your order here, if you kind of pick an angle to start at and you work your way around, angle, you hit another angle, and then you hit a side, right? So it's actually written for you in the proper order on your picture. So that can sometimes be helpful. All right, let's look at number 5. Who can tell me some things they notice about number 5? Yeah, absolutely, Elle. We have another set of vertical angles. So we have our bow tie shape. So there's one set of angles. Who can tell me something else they notice? Yep, there is a congruent side right here with PQ and TQ. So we have an S and an A so far. Anyone notice something else? It's not a congruent, but it, yeah, look, good job, guys. We have some parallel lines. We have our little arrows, right? These two lines here are parallel. Now, something I want to tell you that's often just a silly mistake people make, parallel does not mean congruent. Two lines can be parallel but be completely different lengths, right? So sometimes people see that arrow and go, oh, parallel, so they're congruent. No, not exactly, but it is helpful to us. Does anyone remember why parallel lines can be helpful in a picture like this? There was something like it on your 5-1 homework, and then back in quarter 1, but we haven't talked about it in a little while. Why would parallel lines maybe be helpful? Do you guys remember your angle relationships? Like same side interior angles, alternate interior angles, alternate exterior angles, and corresponding angles? Do those sound familiar? Okay, they sound familiar to Elle, so that's a start. When you have your bow tie shape, you're going to have vertical angles, but you also might have alternate interior angles. This isn't a relationship that happens a lot. Do you guys remember when you had your zigzag shape or your Z shape, and then it'd be those alternate interior angles that were congruent, right? Like these. Does that sound familiar at all? Okay. So those are the angles that would actually be congruent here. We have our Z shape, and if you have trouble finding it, then what I recommend doing is grabbing a highlighter or something and connecting your shape from arrow to arrow, right? Remember, like we boxed in our corners, and then if you look, there's our Z. So that means that angle P could be congruent to angle Q. Or not Q, I'm sorry. Angle P could be congruent to angle T. So there is another set of angles. So using that information, who thinks they could tell me which theorem this is? If we have angle P congruent to T, we have our set of congruent sides and then our set of vertical angles in the middle. Who thinks they can tell me which theorem this is? It absolutely would be, Colin. It would be angle, side, angle. You got your two angles, and the side that's congruent is the one that connects them. So we would say yes, by angle, side, angle. Now, does anyone notice, is that the only place you could have alternate interior angles? Is that the... Yeah, very good, Al. I just drew my Z there because I felt like it. It doesn't have to go there, though. I could also have a Z shape going the opposite way. And if I had it going the opposite way, that would mean angle S is congruent to angle R. So I could potentially have another set of angles here. Now, angle is not a thing, but kind of pretend like you didn't have this angle here. Couldn't you also use angle side then? Right? We got an angle, we got another angle, we got the side that doesn't connect them. So that's another possibility. Sometimes there is more than one answer, just depending on the picture you're using. Okay? So we tend to just like pick one strategy and go with it, but just something to think about. And then last one on this, number 6. Who can tell me some things that they see about number 6? Yep, I see some 90-degree angles. So those are either congruent or maybe we'll need to use HL. We'll see. What else do you guys see? Oh, very good, Colin. Yep, there is a congruent hypotenuse. It's this side KL and this side FH. And we can tell that it's the hypotenuse because it's across from our right angle, right? So we do have a congruent hypotenuse here. So maybe it will be HL. We have the H part. Do we have the L part? Is there another set of congruent sides? Yeah, we got JL and HF. So there is our set of congruent legs. The leg is just another side in your picture. Doesn't really matter which one. But we have the hypotenuse, which is across from the right angle, and then another side, which would be our leg. So we would say yes by HL. Now, something that I want you guys to notice here is, what if I didn't, like Colin pointed out to us right away that that was the hypotenuse. What if we didn't notice that? Wouldn't we think that here we have a set of congruent angles, a set of congruent sides, and then another set of congruent sides? But if you look at your order here, isn't that the ASS theorem again? And are we going to have an ASS theorem? Angle side side, ASS. Am I going to make you guys write that? Nobody? Nobody? Okay. No, I'm not. It's not a thing. This angle side side only works if it's a right triangle. Okay? And I have like some funny little jokes to help you remember that if we were in person, but that's kind of awkward to do through a Google Meet, so I'm not going to. But just keep in mind, it cannot be the angle side side theorem, okay? Sometimes it ends up being hypotenuse leg instead, but you got to have the right information, which in this case we did. All right. What time? I want to see where we're at with timing. So we get out of here at 11:05. Okay, so we got about 20 minutes. I want to get a couple proofs in. And we probably won't get through all 4 of them, but I at least want to do 2 or 3, and then we will be doing this again next class. So, yay proofs. Couple things that you're going to have to keep in mind here. Your given is still always your first step. Your last step here is always going to be one of our new theorems. Our last reason, we are trying to prove triangles are congruent. So that means your last reason is always going to be side, 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 angle, angle, or angle, side, or hypotenuse leg. Those are just 2 things to kind of think about, okay? You're also going to need to think about your old vocab, like perpendicular lines, like vertical angles, like midpoints, things like that. So let's look at our given. Who can remind me, what's this weird upside down T symbol mean? Perpendicular, very good. So we are given that segment BC is perpendicular to segment CD. Segment BC is also perpendicular to segment BA. And segment AC is congruent to segment DB. That is given to us. And it's also nicely labeled for us on our pictures. So let's kind of evaluate what we have. We want to prove these 2 triangles are congruent. So we kind of want to do what we did here. It's actually the exact same process. We're just writing it down a little bit more formally. Based on what we're given, I see a set of congruent sides. So that's good. We can use that. And then don't we also have a set of right angles here? So because if we have perpendicular lines, don't perpendicular lines make right angles? Yes, no, maybe. Do we remember that? Okay, perfect. Perpendicular lines make right angles. So that means we're either going to need to use those right angles as congruent angles, or if it's a right triangle, we could maybe use what? Yeah, the hypotenuse leg thingy. So maybe that. We don't know for sure, but we'll see. All right, so let's look at what else we have before we write our proof. What else do you guys see that we can say is congruent in this picture? We've looked at our theorems. We have right angles. Maybe we'll need to say they're congruent. We have a set of sides. We've kind of used up our givens. Looking at your picture, what else do we know? Okay, yeah, the one that's given to us, right? Okay, very good. We are given a congruent hypotenuse, so we'll, yeah, BC is congruent, yeah. So if you take a look, we have a shared side again. Remember, our shared side is always, always, always congruent to itself. Shared side. Shared side is always congruent to itself. So we have another set of congruent sides here. So we have a set of congruent sides with BC. We have a set of congruent sides with AC and with BD. Colin pointed out to us those are the hypotenuses, right? So, ladies and gentlemen, is this a right triangle? Yes or no? Yes, thank you. Do we have a congruent hypotenuse? Yes or no? Yes. Do we have a set of congruent legs? Yes or no? Yes. So can I, we have Colin and Ellen class today. So can I show that these are congruent using hypotenuse leg? Yes. Okay. So let's write it down. So in order for this to be hypotenuse leg, first thing is it must be a right triangle. So we better say that these are right angles, which is a good thing we were given some perpendicular lines. So think about our vocab words. Anytime I give you a vocab word, use it. We are given perpendicular lines. You might not have your vocab sheet handy in front of you, but I would definitely get it for next time and for when you do your homework. But our definition of perpendicular line says if lines are perpendicular, then they make right angles. So we can say that angle ABC and angle DCB are right angles. And that is the definition of perpendicular lines. Again, you're given a vocab word, use it. Okay. Now we're out of vocab, but Elle pointed out to us that we have a shared side. So when you have a shared side, we need to say that it's congruent to itself, and we do that using the reflexive properties. So we're going to say that segment BC is congruent to segment BC because it's in both triangles. And anytime you say something is congruent to itself, that is the reflexive property. So now from our given, we had our congruent hypotenuse, and now we have our congruent leg, don't we? If I have a congruent hypotenuse and a congruent leg, do I really need anything else? No, I've actually done what I need to do. We can now say that these two triangles are congruent. We actually have an extra line here. You don't need step 5. So we are going to say that triangle ABC is congruent to triangle DCB by hypotenuse leg. We were able to show we had a right angle, which makes it a right triangle. We were given a congruent hypotenuse, and we found a congruent leg. All right. Hypotenuse leg ones can sometimes be a little bit tricky. This next one should be easier. So here we are given that segment AC bisects segment BD, and that segment AB is congruent to segment AD. That is given. We want to prove that triangle ACB is congruent to triangle ACD. All right, so let's take a look at our picture. We are given a set of congruent sides. So there's our set of congruent sides in our given. Let's then go to our vocab. We are given the word bisects. Does anyone remember what it means if a segment is bisected? Two congruent segments, but yeah, that's okay. It's just because it would be if it was an angle bisector. Now, here's the tricky part, and we haven't talked about this in a while, but this is why it's going to be really important to have your vocab sheet. If you have an angle bisector automatically takes an angle, splits it into two congruent parts. A segment bisector is a little bit trickier though. A segment bisector does not automatically cut it in the middle. A segment bisector isn't automatically going to make two congruent parts. If you have a segment bisector, and I would maybe write this down, a segment bisector is going to make a midpoint. If you have a bisector goes through the midpoint, and then it's actually the midpoint that makes your congruent parts. Okay, we don't deal with a lot of segment bisectors because they're trickier, but the definition of a segment bisector is that a line, segment, array is a bisector if and only if it goes through the midpoint. So if you have a bisector here, can someone tell me what point would have to be the midpoint? What do we think? If that's a bisector, what point has to be the midpoint? Well, so AC is our bisector. AC, it says it's just C. So it says AC is bisecting BD. So that means that C is the midpoint. Does that kind of make sense? Okay. So what we're going to say here is that C is the midpoint of segment BD. And that is the definition of a segment bisector. Okay, so now this part should be a little bit more straightforward. I now have the vocab word midpoint. Can someone who is not Colin or Elle tell me what a midpoint does? Good. It's very good. It's a point that's directly in the middle, so it's going to split it in half. So if C splits this in half, does someone have an idea of what we're going to know? What parts are going to be congruent? Very good. If C is a midpoint, then we know that BC is going to be congruent to CD. So we can say that segment BC is going to be congruent to segment DC. And that is the definition of a midpoint. Good. So now we've used up our vocab, but take a look at our picture. We have a good start. We have a set of congruent sides with AB and AD, and now we have a set of congruent sides with BC and DC. We've used up our given, so now we got to look at our picture. Does anyone see something in our picture that we can say is congruent? Yeah, which ones, I'm sorry? Oh, AB and AD we already know. That was in our given. That's told to us right here. So we have AB and AD. We have BC and DC. Look at how the picture's drawn. Is there another set of sides we can say is congruent? AC, yeah, how come we can say that's congruent, Al? Yeah, it's a shared side. Anytime you have a shared side, if your two triangles are connected, say that's congruent. So we can say segment AC is congruent to itself. It's in both. Segment AC is congruent to segment AC. We did this in the proof before. Someone who's not L or Colin, what property do I use there? Something is congruent to itself. Very good. Yeah, very good. That is the reflexive property. Good. So there is my other set of sides. So take a look at your picture. This is why our labeling is important. Who thinks they can tell me what theorem lets us prove the two triangles are congruent? This is SSS Gannon. Good. Side, side, side. We had 3 sets of congruent sides. Good. All right, I want to run through one more and then I'll leave you guys alone. So here, now does this picture hopefully look familiar to you? We actually already talked about this in number 5 up here, okay? So we've kind of already talked about this one, so hopefully this one should help us make some sense of this. So here we are given that segment PQ is congruent to segment TQ. So that is up here. We are given a set of congruent sides. And we are given that segment SP is parallel to segment RT. So that is given. We want to prove that triangle SPQ is congruent to triangle RTQ. All right, so we have one set of congruent sides to start us off with. And then it gave us that this left and right-hand side are parallel. Think about what we talked about with the one on the front. Parallel lines are good for one thing and one thing only. Does anyone remember what that is? What are parallel lines going to give us? Yeah, the Z shape. Yeah, I'm going to go ahead and probably say that, I don't know, 99% of the time with this, it ends up being your Z shape. It's alternate interior angles. So parallel lines are good for one thing and one thing only, and that is giving us congruent angle relationships. 95% of the time with this, it's our Z shape, which we can have right here. Or you could do it the other way if you want. It'll be a different theorem at the end. So we have our Z shape, which means that we're going to have congruent angles. Won't angle T be congruent to angle P then? Yes, no, maybe? Okay. So angle P will be congruent to angle T. So let's say that angle P is congruent to angle T. And we know that because we had alternate interior angles. So that is our alternate interior angle theorem. So now we have a set of congruent sides and a set of congruent angles. I've used up my givens. Anyone see something else? Based on how the picture's drawn, not Elle and not Colin. Does anyone see something else? If you have your bow tie shape. If you need to, go back to number 5 on the other page. Yeah, we are going to have vertical angles. Thank you, Anna. Yeah, vertical angles here. And with vertical angles, I like to make my life a little easier. And you'll see, I think I do this a lot in your homework. I like to number my angles instead. Remember, when we talk about angles, we can call them by either letters or numbers. Just to make labeling easier, I'm going to call this one angle 1 and that one angle 2. Because we have vertical angles are always congruent. So I can then say angle 1 is congruent to angle 2, and that is the vertical angle theorem. So there was another set of angles. So take a look at your picture. What do we think? Is this side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg? Yes, very good. This is angle, side, angle. We had two angles and a side, and your side connects the two angles, so it has to be angle, side, angle. All right.